Hi dear students. Let's see this question that came in JEE Advanced Paper 2 Physics in the year 2019. The question was from the topic of YDSE. A fairly simple question. Most of the students would have been thrilled to solve this, would have collected free marks. The question was on the scheme of multiple choice correct. But one particular thing, this question had only one correct answer, one particular option correct, and so this disturbed some of the students. As I was talking to some of the students after the exam, and they said that in how can multiple choice question can have single option correct. So let's understand that it's not more than one correct, it's one or more than one correct. So of course you can always have one option correct in one or more than one correct. So you know uh, कुछ बच्चों के साथ ऐसा होता है कि इफ एमसीक्यूज में वन और मोर देन करेक्ट में उनका एक ही ऑप्शन सही आ रहा है, सो दे बिकम दे कम इनटू पैनिक स्टेट. तो ऐसा नहीं होना चाहिए. इफ यू आर कॉन्फिडेंट इनफ, just do it and move on to the next question. Coming back to this question, इस क्वेश्चन में लाइट इज कमिंग एट एन एंगल अल्फा, सो वी विल हैव different values of alpha in a YDSE setup, and a point P is chosen at a distance of 11 millimeters from the center of the screen. There are two slits which have a separation of 0.3 mm, and the distance between the slit plane and the screen is 1 meters. Wavelength of the light has been given as 600 nanometers. So based upon different values of alpha and we have to comment whether there will be destructive or constructive interference. Now the question is pretty simple. Let's call this slit as S1 and let's call this slit as S2. So if you see carefully, these 2 points are lying at a wavefront, so they will have the same phase. So we can say that this is the path difference between the ray, between these two rays up till they reach this plane of the slit. Okay, that means this is the path difference up till they reach the plane of the slit. Now this angle is alpha, so this angle will also be alpha, which means this angle will be, now this is alpha, so this we can say is 90, so this angle will be 90 minus alpha, right? So this distance will be d cosine of 90 minus alpha, which means this is d sine alpha, because this angle is 90 minus alpha. This is 90 minus alpha, so this will be d cosine of 90 minus alpha, that means d sine alpha. So we can say that this distance is d sine alpha, and if you find s2p minus s1p, s2p minus s1p, so we know that this is d, let's if we call this angle as theta, so this will be d sine theta, path difference. We know this from the YDSE result. So this distance will be d sine theta. Okay, and since this theta is small because this is very small, 11 millimeters, so we can say that, and this is 1000 millimeters, so theta will be small, so we can write this as tan theta if the need be, and tan theta we can write as y by d, so this is d y by capital D. So total path difference delta x, total path difference will be this d sine alpha plus dy by d. This is the total path difference, correct? Now if you go back to the options, if alpha is 0, there will be constructive interference at point P. So if alpha is 0, then that means both these rays were coming parallel, so this will anyway become 0, and we have to talk about point P. So if you calculate this path difference for alpha equals to 0, so this d has been given as 0.3 mm, 0.3 mm. So let's convert this into meters. So we'll multiply this by 10 to the power minus 3. Y is 11 mm, this is y, so 11 mm, so 11 into 10 to the power minus 3 divided by 1, correct? So this becomes 3.3 into 10 to the power minus 6, or we can say that this will become 3300 nanometers, right? 3300 nanometers. Now if you see the wavelength of the light, it is 600 nanometers, so which is nothing but 5.5 lambda, right? Which means that this is a destructive interference, because this is 5 plus lambda by 5 lambda plus lambda by 2, which means it's a destructive interference. So of course option A is wrong. If you talk about option B, for alpha equals to 0.36 by pi degrees, there will be destructive interference at point P. So we have to talk about again the interference pattern at point P. the type of interference at point P for alpha equals to 0.36 by pi degree. Now you can see that again this is a very small angle because we are talking about 0.36 by pi degree. So we can write sin alpha as alpha. So for option B, this was option A. Okay. So for option B, we can say that delta x will be d into alpha, and alpha is 0.36 by pi degrees. So you have to convert that into radians, which we will get by multiplying by pi by 180. So this is d into alpha. Sin alpha को मैंने alpha लिख दिया है, plus dy by d. dy की value again dy by d तो अभी हमने निकाला ही था. So this will not change. This will not change. This is 3300 nanometers, right? So if you find this, pi से pi cancel हो जाएगा. ठीक है. D is what? 0.33 millimeters है ना? 0.3 millimeters है D. Yes. So 0.3 into 10 to the power minus 3. ठीक है. And this is 0.36 by 180. 0.36 by 180 तो ये आ जाएगा 1/5 होता 1/500, right? So this will become how much? ये 2 से मल्टीप्लाई कर दें क्या, तो 0.6 हो जाएगा ये 0.6 by 1000. So 6 into 10 to the power minus 7, which means 600 nanometers, right? So this will become 3900 nanometers, which is nothing but 6.5 lambda. So you can see it is 6.5 lambda. So we can say that again it will be a destructive interference, and they are saying destructive interference, and hence it is right. Okay. Option C, 0.36 by pi, again there will be destructive interference at point O. So now we are talking about point O, that means center of the screen. Now it is very easy to see that for like this value we have already calculated. This came out to be 600 nanometers. This was 3300. So y will be 0 for point O. So delta x will be only 600 nanometers, right? Because this part will become 0. 3300 part will become 0. So delta x will be only 600 nanometers, and this is nothing but lambda, which means it's a constructive interference. Constructive interference. So this is again wrong because they are saying destructive. Last option is fringe spacing depends only on alpha, which of course is wrong, because fringe spacing will not depend upon alpha, because fringe spacing is lambda d by d. It actually depends upon lambda, it depends upon capital D, it depends upon small d. It is independent of alpha. Changing alpha will just shift the whole pattern. So you can say that central maxima will shift in one particular direction if you change the values of alpha, but the fringe spacing is not going to change, right? So we can say that it is independent of alpha, and hence you can see only option B was right. So many of the students were, when they did this question, so they were like, क्या कोई गलती कर रहा हूँ, because I'm getting only one correct answer, and it is a multiple choice question. So be rest assured that if you are confident enough, if you have done you have done appropriately, then it can be a case where you get only one option right. In fact, there were more questions in this paper itself in which there was only one option correct in a multiple choice correct question. So that's it. I hope you would have enjoyed the solution. Thank you.